Okay, welcome back, Matrix. Now we're going to look at some practical examples. I have found some questions out of the previous national papers that we're going to look at. So, the one that we're looking at now is the question 3 from the November 2015 paper. Alright, question 3. Mr. Vermeulen intends to cover the 4 interior walls of his living room with wood paneling. The northern side of the house is exposed to the sun during the daytime. Use the floor plan in his house, in Annexure B to answer the following questions. Okay, so there are a couple of practical questions here, and then we're going to look at some modeling questions from it. We're going to have to look at the plan, which I have printed out here, of the floor plan. You can find a copy of this paper in the link below. I've linked all the national papers in the description below. Okay, so the first question asks, give a reason why it is acceptable for the kitchen and the living room to only have one door opening without doors leading into the passage. So if we look, there's the kitchen and the living room, and we'll see that there is no indication of a doorway swinging through there. Okay, this is a nice, fairly straightforward question. So we've got a couple of reasons why we could have this. They only asked for one reason. There's no need for privacy is one example that I've heard. Okay, there's no need for privacy. They also could say that it is cost saving because those rooms don't need to be closed up, so why install doors in something where you don't need them? Okay, the next question asks, which rooms shown on the floor plan will be much cooler during winter? Give a reason for your answer. So, if you take note, the northern side of the house is exposed to the sun during the daytime. This is the north side of the house. They want to know which side will be cooler during winter. Well, we know that in the southern hemisphere, north-facing houses are warmer on the north side, and the sun stays predominantly that side. The southern side of a house will always stay cooler. So our 2 rooms that will be cooler will be the living room and the bedroom. Okay, so we could say the living room and bedroom 2 are cooler. And now you've got 2 marks there. We have to say because they are south facing. Okay, they face the south, so get less sun. Okay, it doesn't have to be a particularly terrible question there. Okay, those were just 2 little opinions there. Okay, next, let's take a look. This is one of the major questions here. Mr. Vermeulen bought wood panels to cover the 4 interior walls of his living room, as shown in the photographs below. So you can see some wood paneling being put in there. The interior dimensions of the living room are 7,04% less than the exterior dimensions, as shown on the floor plan. 3.3.1, show the interior dimensions of the living room floor are 3,3 meters by 3,3 meters. Okay, so we're going to have to jump back to our floor plan again. Looking at the floor plan here, the dimensions of this room, the living room specifically, we can see that these dimensions that are pointed out here are 3,550 millimeters. Okay, because this is a plan, measurements are given in millimeters, it's also stated there. And this width of the living room is the same as the width of the kitchen, which is also 3,550 millimeters. They want us to show that the interior dimensions are actually 3,3 meters. You can do this in 2 steps. So I can take 3,550 and subtract from it 3,550 times, I like to do this, 7,4 over 100. Okay, you can use percentages. I'm particular, I either do it this way or using decimals. So 3,550 minus 3,550 times, as I said, 7.04 over 100. That gives us 3,300,08 millimeters. Okay. This 3,300,08 millimeters, if we divide it by 1,000 to get meters, we get 3,3, and then with the rounding, that 0,008 falls away, and so we have that as our simple dimension. Okay, so we've done this part of the calculation and that, so we have to answer the question now. The dimensions are meters. Okay, we've answered the question. Always make sure that you answer the question. It's usually your last thing. Then, determine the total surface area to the nearest square meter of the interior walls of the living room to be covered with wood panels. And then the following formula can be used. Okay, so we can use the area of a rectangle is length times width. I'm going to have to look at my room again. So now we're just focusing on the living room. It would be simple if we just had a room without any holes in it. So no doorways and no windows. But we have those. Thankfully, we've been given the measurements for these windows and doors. Okay, so that is W1, window opening has those dimensions. I've got 1 and 2 normal doors with the swings, so that's the standard door opening, and then the door opening to the passage is another one. So we're going to have to tackle this in a few parts. I can work out the area of a single wall without anything being taken away from it. Multiply that by 4 because we have 4 walls. And then we are going to also have to take away the places where there are doors or windows. Okay. Another thing to note, they have given us the internal height from floor to ceiling, so I can work out the area of my wall. Great. So, if I read from my plan, okay, the area of one wall is equal to, we've already got the dimension, 3,3 meters, okay, and the internal height is 2,560 millimeters, so that's 2,65 meters. So the area of a single wall is 3.3 times 2.65. So we are looking at 8,745. Don't round off until we get to the final answer here, guys. Don't round off. Fantastic. We also have to take out the area of a window. Okay. And my dimensions of my windows are 1,511 times 0,949. I'm doing my conversions now so that I don't have to worry about doing finicky conversions later with square meters, etc. 1.511 times 0.949, double check, yes, I get 1,000,433,939. Okay, for prosperity's sake, I'm going to keep it as unrounded as possible. Alright, let's take a look at the area of the doors now. Give myself some space here. So, area of the door. My door dimensions that I've been given are 2,032 by 750 millimeters, so 0,008. 0.750. I don't need to keep that 0 on the end, but let's just keep that up. So 2.032 times 0.75. You are left with an area of 1,524 square meters. I'm going to put in my square meters here so that I'm not forgetting about my units. Okay, and my area of the opening is going to be 2,082 times 0,750. Okay, so that will give me 1,5615 meters squared. Now, after all of this, we still haven't actually got to our final answer, to the nearest square meter. So, the total area. I need 4 walls. Okay, so 4 times 8,745 minus the area of the window. We only have one of them, 1,433939. Taking away 2 doorways, 1,524, and we're taking away 1 opening, 1,5615. Alright. So punch that all into my calculator, and we see what we have. So that's 74 minus 1.433939 minus 2 times 1.524 minus 1.5615. Okay, so I get 28,936,561. They wanted to the nearest meter. We round up. 29 square meters will be used for this part here. Right, so now we've looked at 3.3.2. We need to look at the next question, which is 3.4, following on from here. The wood panels are sold per cubic meter, not per length. It's a bit of an irritation, but fine. The timber retailer gave Mr. Vermeulen a quote of 5,000 Rand per cubic meter, excluding 14% VAT. This is an old paper, so we're using the old VAT rate. He's noted each wood panel is 2 meters long, 150 millimeters wide, and 12,5 millimeters thick. 4.5% more than the required number of panels is required due to cutting and wastage. Okay, so we've got a bit of rounding up to do there. The labor cost for the paneling is 125 Rand per square meter, including VAT. He budgeted 6,000 Rand for the cost of the panels and labor. Verify whether Mr. Vermeulen's budgeted amount is enough to cover the cost of the panels and labor. Use the following formulae. You've got the area of a rectangle and the volume of a rectangular prism. Okay, so where do we start here? Well, we've already done some calculations here where we've worked out the total surface area of this room. Okay. The labor is quoted per square meter, and the cost of the materials is going to be per cubic meter. Okay, so we need the thickness of the panels, okay, so that we can get the volume of the wood that's held. Now, I'm going to take the simplest route here. The wood panel is 2 meters long, doesn't really help me much. It's 150 millimeters wide, not really helping much, but 12,5 millimeters thick. That gives me some sort of calculation there so I can get the volume of wood required. Okay, I'll work out the volume of the wood required first, and then add my 4.5% extra for the wastage. Okay, and then I will add my VAT onto that as well once I've calculated the basic cost here. Okay, so let's go. So 3.4. First things first, I want to work out the volume of the wood required. So the volume is 29 square meters multiplied by 12.5 millimeters. 12.5 millimeters. We have to divide that by 1,000. So that gives me 0,0125 meters that we're going to work off there. So 29 multiplied by 0.0125 gives me a total of 0,3625 cubic meters of wood. Then we want to add the extra. Okay, so the volume plus the extra for the wastage. So 0,3625 plus an extra 0,3625 times, they said 4.5%. Okay, so I'm going to go 0,045 there. Okay, 0,045. It's another way we can express our percentages. 0.3625 plus 0.3625 times 0.045. We have 0,378812 cubic meters of wood. So the cost of the wood, ex VAT, because that's important, would be 0,378812 multiplied by 5,000, because it's 5,000 rand per cubic meter. So it's cost you 1,894 rand and 6 cents, excluding that. Okay. Now we want the cost, including the VAT. So if you remember, I use this method. If I want the cost inclusive of VAT, I have my exclusive VAT here. What I want is 114. What I have is 100. Okay, so 1894, 6. Will give me 2,159 rand and 23 cents for the wood. Okay, so we're happy with that. So that's the cost of the wood, including the VAT. Then I need to look at the cost of labor. So the labor costs is going to be 29 square meters by 125 rand per square meter, including that. This is my nice simple one. So I have 3,625 rand there. So total cost will be 2,159 rand 23 cents plus my 3,625 rand. So the total cost, 2,159 23 plus 3,625 will be 5,784 rand 23 cents. Okay. They asked us, he budgeted for 6,000 rand, verify whether he has budgeted enough. It's verification, so you're required to give us the last answer. Yes, he has budgeted enough. Okay, so he's budgeted enough. We're happy with that. Okay, and those would be your 12 marks. Okay, fantastic. All right, Matrix, let's look at an example regarding models or coming from plans. Okay, so let's take a look. We're looking at a past paper question from the November 2017 national paper. Right, question 3.2 and specifically, Annex E shows the floor plan of a rectangular room that Lizette wants to add to her property. The room will have a roof and a ceiling with cornices. Okay. Other information, the exterior measurements of the rooms are 5,240 millimeters by 4,040 millimeters. The walls have a uniform thickness of 220 millimeters. The ceiling boards only cover the internal area of the ceiling. The cornices, a decorative edge, were placed between the walls and the ceiling, right around the room. So now we've got an area question and possibly a perimeter question coming in there. Okay, and they give us the formulas: area of a rectangle and perimeter of a rectangle. Okay, and just for good measure, there is our room. As you can see, rectangular. They've given us these external measurements each way, indicated where the doors are and the window is. And then the other thing that they show us is what exactly a cornice is. There's your ceiling, there's your wall, and it's a strip that runs around the decorative part to make it look a bit nicer there. Okay, that's enough faffing around. Calculate in square meters the floor area of the room. Well, the first thing is, we can't just dive in and be all gung-ho about this. We're told that we only have the exterior measurements. We don't have the interior measurements of the room. Okay, so the first thing that we're going to have to do for 3.2.1 is to get the length and the width of the room. Okay, the length of the room according to the plan is 5,240 millimeters. But now we've got two walls on either side. Each wall has a thickness, all right, of 220 millimeters. So I need to take away that 220 millimeters twice to get my thickness of my walls here, or my interior dimensions of my room, should I say. So I need to take away my 220 twice, and I get 4,800 millimeters. Same thing with my width. I'm told that my width is 4,040 millimeters, and I need to take away that 220 twice as well, because we have two walls there. So 4,040 minus 220 is going to give me 3,600 millimeters. The next thing they asked us was to actually give these dimensions in meters. So the millimeters we just have to divide by 1,000. So the area of the floor is going to be 4,8 meters multiplied by 3,6 meters. So 4.8 times 3.6. You're going to have a total floor area of 17,28 square meters. Okay, it's always going to be useful for us there. 3.2.2. Okay, next part, the dimensions of each of the ceiling boards: 900 millimeters by 2,400 millimeters, so 0,9 by 2,4 meters. Determine, showing all calculations, whether a minimum of 7 ceiling boards will be needed for this room. So we have two ways of answering this. I'm going to do both of them. First, require us to find the area of a ceiling board. Okay. So as I said, the area is 2,4 meters by 0,9 meters. I'm using meters because I have to compare to my previous question there. So 2.4 times 0.9 is going to give me a 2,16 square meters area. Now this is where I diverge on my two options. Okay, option number one, not necessarily the best one. We can say 7 times 2,16, all right, gives us the total surface area that those 7 boards can cover, which gives us 15,12. Okay, 15,12 square meters. Therefore, it's less than, okay, 15,12 is less than your 17,28. Sorry, I should be putting in my measurements there, okay, my units. So there's not enough. So 7 is not enough. My other way, which I probably would prefer, is to take my 17,28 and divide it by that area of 2,16. Put an extra 1 there, 2,16. That will give me an answer of exactly 8. So now I can say, no, 8 boards are required. Not 7. Okay, fairly straightforward actually. It's quite a nice question. Okay, so not too bad there. The next question asks us, calculate in millimeters the exact length of the cornices needed for this room. Right, so what I now need to look at is the perimeter of my room. Okay, so the perimeter of my room, 3.2.3. The perimeter of the room is going to be my length of 4,8 plus, oh, and they want the perimeter of a rectangle, so I must use my formula. 2 times length plus width of 3,6. Okay, because they gave me a formula, I should use it. 4.8 plus 3.6 gives me 16,8 meters that need to be covered by our cornices. And the final part of my question then asks me, table 5 below shows the list price of the materials that are being used. Okay, she states that the cost of the materials, seating boards and cornices including the VAT will be less than 1,250 Rand. Okay, these prices include VAT, so we don't have to do any weird calculations there for VAT. Verify, showing all calculations whether her statement is correct. Now they're trying to trick us. They've given us 2 seating board choices there. You have to choose that one, because that is the dimension that they gave you for the seating boards earlier. Alright, so be very careful. Those are the dimensions that they gave you. You're going to use the 91 Rand 44 here, and not the 114 Rand 31 cents. And then there's the molding. It's a cost per length. Okay, we're not going to cut the lengths up, so I'm going to have to figure out how many lengths I will need to buy in order to get that. So let's tackle the lengths of the cornice first. Okay, so the number of cornice pieces that I will need, I need to take my 16,8 meters and divide it by 2,000 millimeters, which is 2 meters. Okay, I know it's funny using a calculator for such a simple question, but it gives me 8,4. So that means that I need 9 lengths. Okay, 9 lengths are required. So the cost will be, we've already figured out we need 8 seating boards. Okay, so we'll have 8 times the seating board cost of 91 Rand 44, and we will have 9 times the cost of the cornicing at 53 Rand 64 per 2,000 millimeters. So 8 times 91.44 plus 9 times 53 Rand 64 will give me a total cost of 1,214 Rand and 88 cents. Sorry, not 88, 28. 28 cents. Okay. So, verify, is she correct? She said it would cost 1,250 Rand. We've got 1,214 Rand 28. So, yes, she is correct. Okay. Awesome. And that question is done and dusted. Okay, Matrix, let's take a look at another question from the national papers. I'm looking at question 1.2 from the November 2018 paper. Okay. So this carries on with the story here, but this is relevant to our models. So, after this person's bought the bakkie, she decided that she wants to paint the cargo bin, the loading box of her bakkie with rubberized paint. Okay, the spread rate of the paint is 0.25 square meters per litre, and it's sold in 5-litre tins. There's a photograph in Annexure A, as well as a simplified sort of model of our box there. So that's what the back of the box would look like. There is our loading box, including the dimensions. We've given us all the heights and lengths and widths in meters. Okay. So, the cargo bin does not have a flat surface, therefore the surface must be increased by 2% to accommodate the uneven surface, because you put those ripples in there for, water to drain out, etc., etc. Okay. So, calculate how many litres of rubberizing paint she needs to buy in order to paint the cargo bin of her bakkie. You may use the formula. So when they say you may use the formula, I generally read it as you must use the formula, or don't be stupid, use the formula. Okay, use the formula of the open box. Width times length plus 2 times length times height plus width times height. Okay, so I'm going to rewrite that formula there, and then we're going to have to work out the costs on that. So, first things first, they want us to do the surface area. Okay, so the surface area is equal to my width times my length plus 2 times length times width, height, plus my width times my height. Okay, nice and simple. Let's read that off my dimensions here. I'll fold it so it's easier for us to see. Okay, width 1,374 meters. My length is 1,807. Okay, and then plus 2 times length times height. So length 1,0807 times my height 0,535. Okay, let's get that out of the way. Right, and I'm adding to it. Let me just save myself some space here because I'm going to run out here. My width times my height. So 1,374 times my height of 0,535. Okay. Alright. Let's plug that all into a calculator so that we can get this as simple as possible, just for the surface area that we are looking at. So 1.374 times 1.087 plus 2 times, open brackets, 1.807 times 0.535 plus 1.374 times 0.535, close brackets. Okay, so my area will be 5,886488 square meters. We have to add the extra as well. Okay, so with the extra, I'm going to have 5,886488 plus 5,886488 times 2%. Okay, so 5.886488 plus 5.886488 times 0.002. Left the decimal out there. Watch out for your decimals, guys. Gives me 6,004217776. So they would like it to be how many liters? Okay. Well, we've got the square meterage that is being covered here. It's about 6 square meters, right? And we know that the spread rate is a quarter of a square meter per litre. So I'm not going to round off here. So 6,00421776 divided by 0,25, because I want to see how many litres I need. I need 24,01. Let's round it off to 0,2 litres here. The tins are sold in 5 litres. Alright, so that's going to be our next thing that we're going to look at after that. So we know how many litres they need to buy, just over 24 litres. That makes our next question quite easy, because if I take 24,02 and divide it by 5, I find out how many tins she needs. 24.02 divided by 5. We know it's going to be an infinitesimally small number, 4,804. We round it off to 5 tins. Okay, 5 tins. A 5 litre tin costs 549 Rand. So the cost will be 2,745 Rand in total. Okay, this is my cost for putting on 1 coat of paint. Alright, so the total cost is going to be twice that, at 2,745 times 2, which is going to be 45 times, already times by 2, 5,490 Rand in total to cover the paint, or the load bed. Okay. Now, 1.22, explain the significance of applying the rubberizing paint to the cargo bin of the bakkie. Okay. So, last page, yes. And I've torn it. Oh well, that doesn't matter. So, what do we want here? 1.2.2. Why are they covering it? Stops things from slipping. It's more hard wearing. Or any other, probably any other answer there. Finally, 1.3, they tell you it takes 20 minutes to apply a layer of rubberizing paint. There is a 4-hour waiting period between the second coat of the rubberizing paint can be applied. In addition, a further drying time of 2 hours is required after the second coat has been applied. Determine with calculations what time the bakkie would be ready if the workshop started rubberizing the bin at 8:15. So, it takes 20 minutes to apply a layer of paint. We're applying 2 layers of paint. So 2 times the 20 minutes. Then we have to wait 4 hours in between. And we also need to add another 2 hours after the paint has been applied for it to finally finish. Okay. So, altogether, I get 6 hours and 40 minutes of time that it will take to apply everything. If we started at 8:15 and we're adding 6 hours 40 minutes, 6 and 8 gives me 2, so I will get 2 o'clock. I will get 1455. Okay, right, so it'll be ready at 5 to 3 in the afternoon if they started at 8:15 in the morning. Right, let's look at another question from a national paper. Now we're going to be taking a look at a question from the November 2018 national paper. question 3.4. All right, this was the follow-up question to one where they were talking about a race organizer. There was a foot race and there was a plan there and you had to determine a whole bunch of things. But we're going to focus on the model here. So, more water must be taken to refreshment stations. The water be transported in cylindrical buckets with lids, the maximum capacity of 20 litres. Cylindrical buckets containing water with lids are shown below. There is just an example of what the bucket would look with the outside diameter of 31.2 centimeters. The bucket walls are 2 millimeters thick, so the interior walls are going to, well, the interior dimensions are going to be a bit smaller then. You can also see how they're put on the rectangular pallet. The pallet is 120 centimeters or 1.2 meters long. The width is 100 centimeters or 1 meter wide. Okay, and then we can see our 312 millimeter diameter of the bucket there. Okay, there's also a space indicated here as C, which will come up later in one of the questions. So, first things first, we need to work out the maximum height in centimeters of the water in the buckets if the outside diameter is 31.2 centimeters. You may use the formula cylinder is pi times radius times height, where the pi is 3.142 and 1 litre is 1,000 cubic centimeters. Okay, so we're going to do a little conversion here. The maximum capacity of these buckets was given as 20 litres, so we're working back from there. So, very first thing we need to look at, 3.2, we're looking at 3.2.1 in particular. Okay, so we know that 20 litres converts to 20,000 cubic centimeters. All right. The volume of a cylinder was given, so my volume is 20,000. Oops, too many zeros. 20,000. Okay. My pi is given as 3.142. My radius that I'm given, all right. Well, radius we need to work out quickly. So, just on the side, my radius is going to be half of my diameter. All right. So my radius is equal to a half of 31.2, which is going to give me 16.1 centimeters. Right. We also need to take off the 2 millimeters of the thickness as well, because we're looking at the interior diameter here. Okay. So my radius needs to have 16. Okay, we're timesing it by 10, so 161 millimeters minus 2 millimeters will equal 159 millimeters. Okay, so I'm going to put my 159 millimeters in there as my radius. And they want to know what's the maximum height in centimeters the water can have. Okay, so I don't have that h. So I'll have to work this all back there. Okay, so what we land up with is h is equal to 20,000 divided by 3.142 divided by 159 millimeters. Oh, we're working in centimeters here, sorry. So it should be 15.9. Yeah, 15.9 all squared. Okay, so 20,000 divided by 3.142 divided by, oops, I said minus there, divided by, I use my brackets, 15.9 squared. So we get 25,1785, which they want us to give it in centimeters. Okay, they don't ask us for the closest centimeter, so 25.18 centimeters is probably the closest we're going to get there in that answer. Okay, Alright, so that's all fine and well. Don't get too mixed up there. Okay, I only took off one of these 2mm here because I'm only looking at the distance from the center of the bucket to the outside edge, and so that only accounts for one wall, not two of them. Okay, 3.2.2. The buckets are placed on the pallet as shown in the diagram above. Calculate the unused area in cubic square centimeters of the rectangular floor of the solid pallet. You may use the area of a circle is pi times radius squared, where pi is 3,142. So the area of the pallet is equal to, we're looking at 120 centimeters by 100 centimeters. So 2 centimeters squared. Okay, we're looking at 12,000. No, there should be an extra zero in there. Yeah, 120,000. We are having a bit of a maths problem this morning. It was 12,000. Don't second guess yourself. 1, 2, 3. Okay, 12,000 square centimeters there. Okay, the area of one bucket is equal to pi, which we know is 3,142, times the radius, which we've determined there earlier, 15,9 centimeters. Okay, 15,9 centimeters squared. So 3.142 times 15.9 squared will give me 794,32902. I'm not rounding that off because we want to get the exact amount there. So unused area is equal to 12,000 minus, and the number of buckets that they put on this pallet. Number of buckets, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we have 11 buckets on there, so we're going to take 11 times 794,32902. Okay. Okay, multiply that. 0.9432,902, and we get an area of 3,262,38. Okay, I think it'll probably be close enough that we are there with that much unused space. Okay. Then they also want to know what is the size of C here, where it hasn't been covered. Okay. So we have 1, 2, 3 full buckets widths there. Okay. So C will equal the 120 centimeters minus 3 of our bucket diameters. Okay, and we're looking at the outside diameter of the bucket here because the walls have to be included here. Okay, so C will equal 120 minus 3 times 31.2 centimeters, and we get C is equal to 26,7 centimeters total. Okay, so that's all fine and well. Let's take a look at the next part. Right. Finally, they say, the organizer would have preferred each pallet to have 12 buckets arranged in 3 rows of 4 each, so they're adding an extra bucket. Calculate the percentage by which the length of the pallet should be increased to accommodate the new arrangement. Okay, so we need to consider how much longer it should be. I've got a couple of ways that I could work this one out. Okay, the increase would actually be the difference between C and the diameter of a bucket. Okay, so that's one way I can do it. So I could look at this as 3.2.3. I'm going to take the 26.7 that I had in my earlier question, okay, and I'm going to find out the difference between that and our diameter. 26.7, sorry. Alright, 31.2 minus 26.7 is equal to 4.5 centimeters. And then I just say that 4.5 centimeters divided by 120 to find out what the percentage of the original distance or the original length this is. So that is 3.75%. Okay. The other way that I could do it, alright, is to work out what my new, okay, so I could look at an or here, I could look at my new length, so I know that I need to fit 4 buckets in a row, so 4 times 31.2, 4 times 31.2 is going to give me 124.8 there, okay, 124.8, then I go and see what our percentage change is. So percentage increase is equal to new minus old over old times 100. Okay, you're not necessarily always given the formulas that you need in paper 2. So my new is 124.8 minus my old, which is 120. Okay, divided by my old, which is 120 times 100. So let's go look at 124.8 minus 120 over 120 times 100, and that gives you around 4%. Okay. The reason why this came up is because of the differences here. Okay, I had to do some rounding off in this earlier question just to reiterate that. Minus 3 times 31.2. Oh, I miswrote. That's what I did wrong. I miswrote. My apologies. So this is in fact 26.4. And that would mean that here I've got 26.4. So 31 minus 26.4. 1.2 minus 26.4 gives me a difference of 4.8, and that would give me a 4% change. Okay, there we go. Oh, good. So double checking it my ways, I can see that I made a mistake in the earlier question. Okay, don't worry if you made a mistake in the earlier one. They would work with your mistakes and give you carry marks into this question, so you wouldn't lose the 5 marks that you would have had here. Okay, so thank you very much.